In 10.2, we are going to go through graphing parabolas. Now in this section, we're going to also do a portion of 10.6, the portion that relates to graphing parabolas that are not centered at 0, 0. So when you look at parabolas, they have two different forms. They have a vertical form and a horizontal form. In the vertical form, you'll see that x is being squared. So if x squared is equal to 4 times p times y. And that's the parabola you're used to from graphing quadratic equations. When you're graphing a quadratic equation, x is being squared, y is to the first power. In the horizontal version, y is being squared and x is to the first power. So a vertical parabola, as you're already used to, is either going to open up or it's going to open down. That depends on the coefficients. And the horizontal is either going to open left or right. Right? And if we are going to graph a parabola has, I'm going to look at a vertical parabola with a positive value for p. It's going to have some parts. It's going to have the parabola that we're used to. It's going to have a point that's a focus. The vertex is on the center, and there's a line called the directrix. These are all parts of our parabola. If we looked at that in a horizontally oriented parabola, we'd have the same thing. We'd have a focus here, we'd have a center for our vertex, and we'd have a vertical line instead of a horizontal line. Okay, so when the parabola is oriented vertically, the directrix, that's this line, is oriented horizontally. When the parabola is oriented horizontally, then the directrix is oriented vertically. So I locate the focus and the directrix based on this value here, this value of p. So whatever coefficient we have with the variable to the first power, we need to set that coefficient to be equal to 4p so that we can then find what p is, right? So we got 4p right here, and we have 4p right there. When we find what p is, then we can find the distance that p is from the center of our parabola, which is the location of the vertex. Right now, our vertex is going to be at 0, 0. Okay? So these are special case. Later we'll get into how we work when the vertex is not at 0, 0. The vertex is the center of the graph of a parabola. So if I want to find p in this particular problem, you'll see that 16 has to be 4p. So if I set 16 to be equal to 4 times p, then I can find out that in this problem, p is equal to 16 divided by 4, which is 4. So if I write this with p in the problem, see, x squared will be equal to 4 times my value of p, which is 4, times y. What that means is that the focus is going to be 4 units above the vertex, so it'll be at 0, 4. That's going to be my focus. And it means that my directrix is 4 units below, right? So that's a horizontal line. Y is equal to -4. So right here, this is 0, 0. So if I want to find my focus, I go up 4. If I want to find my directrix, I go down 4. Part of the relation here with parabolas is that every point on this parabola is an equal distance from the focus and the directrix. So the distance from here to the focus and here to the directrix, these would be the same. And the distance from here to there, those would also be the same. Okay, so that's why the directrix is in there. So the key part in doing this is for me to know what the center is, and right now the center is at 0, 0. And find p, because p is going to tell me how far do I move from the center to find the focus or to find the directrix. Okay, so in this case, y squared is equal to negative 14x. Y squared is equal to negative 14x. I know that negative 14 will be equal to the 4p, right? Because it's the coefficient with x is equal to 4p. So if I divide by 4, I'll have negative 14 over 4 is equal to p, which is going to be negative 7 halves. Okay, so p is equal to negative 7 halves. That means that from 0, 0, this is 0, 0 right here, I'm going to go, actually this is not going to be oriented in that direction. It's going to be oriented in the other direction because I'm going to move negative 7 halves and I'll have my focus. My parabola is going to go like that. And I'm going to go 7 halves, the opposite of p, to find my directrix. Okay, so this is sort of it in an overview. Now let's go ahead and do this on a graph. Okay, so again, I know that x squared is equal to 4py. That means that the 4p is equal to 16. Right? I also know that this is going to be a vertically oriented parabola because x is what's being squared. So to find p, 16 is equal to 4p, so p is equal to 4, which we already did. We know that our center, which in this case is also our vertex, is at 0, 0. So I'm going to move up 4, 1, 2, 3, 4, to find my focus. And I'm going to go down 4, 1, 2, 3, 4. This is where I would find my directrix. It's going to be a line through negative 4. So my focus here is at 0, 4. My directrix is a line y is equal to negative 4. And all of this was based on the value of p. So this distance is p, which in this case was 4. And this distance was the opposite of p, which in this case was negative 4. Okay? Now, I need to get the details of my parabola, and we're going to do the same thing we used to do when we were doing quadratic equations. We're going to pick values of x. So I could pick, 1 and 2 over here. I know I can match them with symmetry to the other side. When I plug 1 into my equation, 1 squared is equal to 16y. So when I solve for y, I'll get 1/16. I'll get 2 squared is equal to 16y. When I solve for y, I'll get 1/4. So I'm going to have a point here and a point there. I can match them with symmetry over here. And this is the shape of my parabola. Right? So I've identified these important aspects. I've got my focus. I have my directrix. And then I did my input-output table, which allowed me to create these points. And I put in my graph. Right? So that's what you're going to want to do when you're graphing a parabola. Now, if my value of p had been a negative value, then I would have gone down to find the focus, and then I would have done the opposite of that to find the directrix, and this would have been oriented downward. So you can see when this coefficient is negative, the parabola is going to open down, just like we did when we did quadratic equations. When the leading coefficient was negative, it opened down. Okay. Now to look at a horizontally oriented parabola, I know it's horizontally oriented because y is what's being squared. I know that negative 14, right, this is the form we're working in, y squared is equal to 4px. I know that negative 14 is 4p. So if I set negative 14 to be equal to 4p, then I divide by 4. P is equal to negative 14 over 4, which would be negative 7 halves equals p. I know my center right now is at 0, 0. So if I want to find the focus, I'm going to go left. I'm going to follow p. Negative 7 halves is p. 1, 2, 3 and a half. That's right there. So I have negative 7 halves, 0 is my focus. My directrix, I'm going to do the opposite of that. So I'm going to 1, 2, 3.5. And I know 1, 2, 3.5. I've got my directrix is over here. And then I'm going to do an input-output table. Now, normally we pick x's, but I suggest you pick whatever's being squared. Right? So if I pick values of y that are 1 and 2, when I square this, I'll have negative 1/14. And then when it's 4, when y is 2, 2 squared is 4 divided by negative 14, that'll be negative 2/7. Okay, if I go ahead and graph these items, when it was 1, it was negative 1/14, 2/7, and I match them with symmetry on the other side. Again, I have this very shallow parabola. And that's what we need to do. We've got our focus, we've got our directrix, which is x is equal to the opposite of p. In this case, the opposite of negative 7/2 is 7/2. And I've got my input-output table that allowed me to make these points. Okay, so that's graphing a parabola when it is centered at 0, 0. If I want to write the equations of these graphs based on supplied information, standard form 0, 0, they could give me all sorts of different information. Okay? They could tell me where the focus is, they could tell me the directrix, and all of these will allow me to write the equation because the focus, the coordinates of the focus, or the equation for the directrix will allow me to find p, and that's what I need to find. Okay, now notice, if my focus was on the x-axis, negative 2, 0, that means that from 0 we went negative 2 to find the focus. This is what this parabola is going to look like. Right over here, this has a directrix that is y is equal to negative 3. That's a directrix that looks like this. This parabola goes in this direction. Okay, this one has a directrix x equals 3/4. That's over here. That means this parabola looks like that. And here they've given me a focus. We always wrap around the focus, 0, negative 3. So if my focus is down here, negative 3, that means my parabola is going to do this. Okay, so this helps you understand. So this is y is being squared, so I was going to use y squared equals 4px. Okay. Here, this is x squared equals 4py. On this one, it's y squared equals 4px. And on this one, it's x squared equals 4py. Okay. Another quick way to think about it is that if the focus is on the x-axis, see, then x is to the first power. If the focus is on the y-axis, y is to the first power. If the directrix is an equation y equals, then y is to the first power. If the directrix is x equals, x is to the first power, and that will help you know which form you're in. So in this case, p is equal to negative 2, and when I plug the p into this, I'll get y squared is equal to 4 times negative 2, which is negative 8, x, and that's the equation of this parabola. In this case, right, p is the opposite of the value for the directrix, so p will be equal to the opposite of negative 3, which is 3. So x squared will be equal to 4 times 3 times y, so x squared is equal to 12y. Down here, my focus, p is negative 3. Remember, p comes directly from the focus. The directrix gives you the opposite of p. So negative 3, so I'll get x squared is equal to negative 12y. And over here, the opposite of 3/4 is p, so that will be negative 3/4. 4 times negative 3/4 is going to be negative 3x. Okay, so that's how we write the equations of the parabolas. You just have to use the information that you use to graph, but use it in reverse to identify what P is, plug P into the equation, and then you're able to write the equation. Okay, that's all relatively simple. Now from 10.6 we deal with parabolas that are not centered at 0, 0. So you'll notice that, as I've been telling you in other forms, K is with Y,